Okay, next I want to get into the idea of regression. Now, regression is different than correlation, where correlation just says there are relationships amongst the variables. Regression is much different than that. In regression, what we try to do is we try to use one variable to predict the outcome for another one, at least in simple linear regression. Can we use one variable to predict the outcome for another? So in this case, what would it be with the case I just went over? If it's BMI and snoring, can we use BMI data to actually predict how much snoring and sleep apnea will be the case? And the idea there is, if you look again at the scatter plot, it looks like there is indeed a relationship that you should be able to use BMI to predict snoring. And the first thing that we do with this, and we're not going to go through all the math on this because we're doing this as an online course, but what you normally do is computers can come up with a best fitting line equation. And page 529 of your book goes over that a bit. And what we try to do is we try to predict what the snoring score should be if we know the BMI. And so we try to do a prediction, and if you look at my information there, I put the best fitting line equation there. Y hat equals 6.25x minus 185. You basically put all the numbers in. SPSS will show you the output. Y hat is the predicted snoring episodes. So if you were to draw a best fitting line across all those points, the idea would be that best fitting line, if you put in the snoring episodes, you could predict put in the BMI, you could predict the number of snoring episodes. Y hat is the predicted value. 6.25x stands for that 6.25 that's next to the BMI. You would basically put 6.25 and then you would put the BMI score in there, and then you'd subtract the 184.7. I rounded to 185 to see if you could predict things. So you make a best fitting line equation to see how well BMI could predict snoring. And so that first table there gives you the information for the best fitting line. The second table, the model summary, I've highlighted in boldface something called the adjusted R-squared. Page 524 tells you that's called the coefficient of determination. And this is a very important thing that you want to write down. The coefficient of determination, the adjusted R-squared, basically tells you the following. If you know the BMI, how much of the snoring can you account for? If you know the BMI, how much of the snoring can you account for? And in this case, it tells you that if you know the BMI, you can account for about 78% of the variability in snoring. Now, does that sound good to you? If you know one variable accounting for 78% of the pie? Yeah, that's very good news. One variable that can account for or predict 78% of the variability in snoring. The total amount possible is 100%. So if you know one variable and you can account for 78%, that's a really good thing. The final table, the ANOVA table down below, tells you that basically that 78% is statistically significant. That's the 0.029. So the way you would write this out, and a regression can be done with an ANOVA, you'd write out f of 1, 3, regression and residual, f1, 3 equals 15.5, p equals 0.029, and this would basically say to you that the 78% that what BMI can account for snoring, that percent is statistically significant. So hopefully that makes good sense to you. And I think that'll be lecture number 2. Thank you.